Hi friends, see today I will be starting a new chapter in second year, that is current electricity. Okay, actually from current electricity you will be getting around 4 to 5 marks in MSET. In current electricity you will be getting around 4 to 5 marks you will be getting in the MSET examination. Now first of all, let us know what is meant by current electricity. Let us know about what is meant by current electricity. Okay, current electricity ante enti first of all చూద్దాం. See, already in fourth chapter we have discussed about electrostatics. So there you have studied about electric charges at rest. There you have studied about electric charges at rest and the field produced due to the charges. So here what happens, electric charges if they are in motion, electric charges if they are in motion in any conductor, okay, that phenomenon is called as current electricity. Okay, if the charges are in motion, that means if V is the potential difference between the two ends of a conductor, and if the charge is flowing, then it is called as current electricity. Okay, so this is the definition of current electricity. Now in this, first of all, regarding examination point of view, if you observe the main problems coming in MSET are, just now I told you what is Q, charge. In before chapter already I told you Q is equal to plus or minus NE. Charge is equal to, because N is an integer here, it can take values 1, 2, 3, 4 positive or minus 1, minus 2, minus 3. So N is integer, number of electrons, and E is the charge of the electron, 1.602 into 10 power minus 19 coulombs, and Q is equal to charge. So Q can be also given as I into T. I can write capital Q or small q. So charge I can write it as I into Q, that means Q is equal to I ampere into 1 second. This is also equal to 1 coulomb. Please make a note. So 1 coulomb I can also take it as 1 ampere into 1 second. So 1 coulomb is that charge flowing in a conductor when the strength of current is 1 ampere over a time of 1 second. So like this also you can define 1 coulomb and also 1 ampere. 1 ampere is that strength of current in a conductor when the charge is 1 coulomb over a time period of 1 second. So these are some formulas regarding the current electricity. Now the main examination point of view is, they may be asking how many electrons are there in 1 coulomb of charge. Regularly asking the question. Regular question adutadi. How many electrons are present in 1 coulomb of charge? So use this formula better. Q is equal to Ne. So Q how much? 1 coulomb. N, number of electrons don't know. E, 1.602 into 10 power minus 19 coulomb. Coulomb cancels. So 1 by 1.602 10 power minus 19 is equal to N. If you divide this one, you will be getting around 6.25 into 10 power 18 electrons. So this you can remember in your mind. So ఒక కూలంబ్ ఆవేశంలో ఎన్ని ఎలక్ట్రాన్లు ఉంటాయని అడిగితే 6.25 into 10 power 18 electrons. అలాగే 2 coulombs multiply with 2. Okay, అలాగే 1/4 coulomb divided with 4. Like that you can calculate the number of electrons in the examination, please. Clear? So let us go still further. This chapter is a very easy chapter. Even though it is a lengthy, it's an easy chapter. You can easily score marks. Okay? Now let us go to the next item in this one. Now as I said, charge. As I said, what is charge? I mean strength of current. What did I tell you? Strength of current I. So I is nothing but dq by dt. Rate of charge. Rate of flow of charge in conductor is equal to current, which is nothing but current electricity. Flow of charge. So I can be also given as dq by dt. I can be given as dq by dt. Or this can be written as dq is equal to I dt. So sometimes what happens, if you want to charge, then just by integrating and get q is equal to integral I dt. Okay. If you want the time interval also, you can take t1 to t2. Okay. You can take time interval t1 to t2. This is another formula for charge. For example, this is x-axis and this is y-axis. Already I have told in work done. Okay. Suppose I is on y-axis, strength of current, time. Suppose say the graph is like this. So this area under this curve, how you will get I dt? Area of this curve, A, B, C, D. So area under this curve or integral t1 to t2 I dt, you will be getting the charge value. Okay. How to get the charge value? Area under the curve, under the time interval t1 to t2. Okay. You can just integrate and you can get the value. This is another process. You can calculate the charge value. Okay. If the like this graph problem is given, you can just find the area of the curve or integration I dt under the time interval t1 to t2. Now let us do a small numerical to understand in better fashion. Suppose if q is given as say t square 3t square plus 2t, 3t square plus 2t. Suppose this is the question given for you. Q is equal to, which depends upon time, 3t square plus 2t. For example, say like that. Now is asking you what is the current at t is equal to 2 seconds and at t is equal to 2 seconds, and also is asking you average current from 0 to 3 seconds. So let us solve this problem. I want the current at a time t is equal to this thing. So current కావాలని ఏం చేయాలి? Given equation ని derivative కట్టాలి. What is dq by dt? Rate of flow of charge, current. Derivative d by dt of this one, that is 3t square plus 2t. So this is nothing but 6t plus 2. This is equal to I, derivative. So at t is equal to 2 seconds, I is equal to 6. This is derivative n into x power n minus 1. So 60 plus 2 is 6 into 2 plus 2, that is 6 to 12 plus 2. How much? 14 amperes. So this is how you will be solving such type of problems. If they are giving some function with respect to time t charge. In the same way, average adigadu. How will get average current? Okay, that is delta q by delta t. Delta q by delta t. That means 0 to 3 seconds kabatti charge at 3 seconds minus charge at 0 seconds by time t3 minus t0. Delta q by delta t. So charge at 3 seconds. So put it here. So already you have equation q is equal to 3t square plus 2t. So first put charge at 3 seconds. So 3 into 3 whole square plus 2 into 3. 9 3s are 27. 3 square kada. Plus 2 3s are 6. That is 33 amperes. Now find out at charge at 0. Charge at 0. That is, put time is equal to 0 here. What happens? 0 into 3 is 0. 0. So 0 value. Put those values here. You will get I average. Delta Q3. What is Q3? 33 amperes minus 0 by 3 minus 0. That is nothing but 33 by 3, that is 11 amperes. So this is how you will be calculating I average. I average means average current. So delta Q by delta T. So time at 3 seconds, what is the current you have calculated? At 0 seconds, so calculate finally dq by dt is equal to charge at 3 minus charge at 0 by 3 minus 0. Clear? So this is how you will be solving the problem, please. Okay, clear? Right. Now let us go to the next one. So these type of problems nowadays they are giving in the MCET examination, also in NEET examination, medical entrance. Okay. So practice well, because concept is very, very important. If you know the concept, you can solve any problem, please. Okay, clear? Now let us go to the next version. For example, see here, other type of problems. For example, this electron, okay, it is revolving in this fashion. So this is the velocity of the electron. Okay. Suppose electron is revolving like this in circular. Okay. So sometimes you may be asking in terms of frequency. See, already we know I is equal to what? dq by dt. dq means what? Charge. dt means what? The time taken, one complete time. I can write it as capital T. Time period, time taken for one complete revolution, one revolution. So I, charge, I can also write as q into what is 1 by t? Time period, frequency. So therefore, another formula for charge, strength of current, another formula for strength of current is, you can also write as charge into frequency. Charge into frequency, please. Please note down, this is also sometimes you can apply in the examination when they are asking, when frequency is given. Okay? Right. Now let us go to next version, that is what is drift velocity? What is drift velocity? See, as I said before, electrons are continuously colliding inside any metals. Continuously it will be colliding. So those will not travel so fast. So andike drift velocity of the electrons is around nearly 10 to the power of minus 4 meter per second. Electrons will not flow so fast. They are going very slowly. Why? Because of the collisions. Continuously collisions. Okay, elastic collisions. A collisions vall evautundante slow heavy, almost the drift velocity is 10 to the fraction of millimeter. 10 to the power of nearly minus 4 meters per second. This is the drift velocity. Now what we will do is, we will try to take some equation, find out some equation for drift velocity. For example, this is a conductor connected to a charge. Okay, this is the potential higher, going, again coming, same charge. Okay. Now as you know, this is the direction of current and this will be the direction of electron. Opposite direction. For example, say from P to Q distance, electrons are moving, for example, say number of electrons. Electrons are moving. Opposite direction of this is the direction of current and this is the direction of electrons. Now we will try to take some equation. At the end of we already know what is Q. Q is equal to NE, and we also know Q is equal to IT, that is equal to N into E, or I is equal to NE by T, equation 1. Now you can observe N is number of electrons, E is the charge, 1.6 in 10 power minus 19. Now for example, when the electrons are coming, okay, it is making some displacement, P to Q. So displacement is equal to velocity into time. So it is coming, that means a group of electrons, that means it is occupying some volume. So what is volume actually? Area into length. Okay. So here the current flowing is equal to NE by T into volume. But what is volume here? Volume is equal to area into length. Area into length. And what is the length? Displacement, velocity into time. So Vd into T. So T gets cancelled. So current I is equal to NEAVD. Very, very important formula. where Vd is the drift velocity of the electron, I told you nearly 10 power minus 4 meters per second. A, area of the cross section of the conductor. E, charge of the electron 1.602 in 10 power minus 19 coulombs. N is number of atoms. This is the relation, please. Okay. So I is equal to N E A V D. Very, very important while solving numericals. Clear? Now we will do one thing. We will explain some more terms regarding this. Okay, please note down. We will explain some more terms regarding this one. Okay, clear? Any doubts? So these are the things asking regularly in MSET and NEET examination. Now what we will do is we will try to explain what is relaxation time, another important one. Relaxation time. Relaxation time. This is generally indicated with tau. Tau. So in relaxation time, for example, electron will be colliding. Okay. Electron will be colliding. Okay. When it is colliding, the time gap between one collision and next collision, that is called as relaxation time. The time gap between one collision and next collision. Suppose let the displacement length is equal to lambda, wavelength. So for this collision again it is next colliding to the next one. So a collision ki collision madhyana gap time ne manam relaxation time antam. Now what is the relation for relaxation time and drift velocity? Generally drift velocity is given by A into tau. That is acceleration of the electron into tau, relaxation time. Or drift velocity is equal to, what is the acceleration from Newton's laws? F is equal to ma, or F by m is equal to a. So what is F again? Eq or E. So E by m is equal to a. You can substitute here. A is equal to F by m into tau, or drift velocity is equal to F and A into Eq, or E by mass of the electron into tau. So this is another formula relating drift velocity and relaxation time. So relaxation time and enti ok collisions ki inko collision madhyana time gap. That time lapse is called as, or time is called as time gap relaxation time. Okay? It is indicated with the letter tau. Please write down. That means between any two successive collisions, between any two successive collisions, the time gap is called as relaxation time. The relation between relaxation time and the drift velocity of the electron is given by acceleration into tau, or remaining all the equations you can see. Vd is equal to E, charge of the electron, electric field, relaxation time, mass of the electron, please. Clear? So these equations are very, very, very important in solving numericals for MSET and NEET examination. Okay, we will try to give some more equations regarding this one. Okay. One more thing, that is energy gained. How to get energy gained? See, when it is colliding, you can see when the electron is colliding, okay, between two successive collisions, you are saying the relaxation time as tau. You are saying relaxation time as tau, and you got it as Vd is equal to A into tau relation, and also finally this equation. Now, what is the energy gained? That means work done. Work done is equal to Vq, where V is potential. So, work done or energy gained is equal to V into Q. But what is V? Magnitude. E into L. Potential. Already in electrostatics we have defined. Take magnitude, because already minus will be there here. So, if you take magnitude, potential is equal to E into L. E dot L. You can see in the electric field direction and length are in both directions, same direction. You can see. Suppose this is a conductor here. This is a conductor. Potential plus minus charge. Okay. This is the direction of electrons. And this is the direction of current. Okay. You can see this is the length. So length, field, same direction. Cos 0 is equal to 1. Length and electric field, same direction. So cos theta 1 kabatti, you can take V is equal to E into L. Okay. So energy is equal to, or work is equal to, E into L into Q. So energy gained, I can take a formula as electric field into length. Length I'll take it as wavelength lambda in terms of length, and Q, either Q or small e. So this is the energy gained, please. You rendu E confuse avukanda, I'll write better work W because you'll be confusing. So energy gained or work done, W is equal to E electric field into wavelength lambda into charge Q or small e. So this is the formula for energy gained between two successive collisions, please. Okay, clear? So these formulas you have to utilize while doing numerical problems. Clear? Any doubts? So I have given so many formulas till now regarding drift velocity, current, relaxation time, and also of course work done, that is energy gained. Okay. Now let us go to the next term in this one, that is electron mobility. Electron mobility. Next one is electron mobility. So this is the field direction. Okay. Suppose electron is there. Okay. So electron direction tells the current opposite direction వెళ్తుంది ఎప్పుడు కూడా. Okay. Now mobility mu is defined as drift velocity by electric field. Both are vectors. Mobility of the electron is given by ratio of drift velocity of the electrons. In what fashion it is drifting, that is 10 power minus 4 meters per second, divided by the field. So units and SI units, so meter per second by volt per meter. Because E, what is the unit? V is equal to ED. Volt per meter is equal to E. So meter per second, that is equal to meter per second into meter per volt. Just చూసుకోండి, meter పైకి వెళ్ళిపోతుంది. So meter square, second inverse, volt inverse. This is the SI unit of mobility of the electron, please. Clear? So this is how we will be defining the mobility. Now let us go to the charge density, another important formula. Charge density. Okay? Current density. Current density, please. Another important one, current density. See, generally current density is a vector quantity. It is indicated with J bar. It is defined as current by area. Ratio of current to that of area. Okay, అర్థమవుతుందా? So it is a vector quantity. Current density is given by ratio of current to that of area. That means current per unit area. Okay, so units ఏంటి? Ampere per meter square. Current density is a vector quantity. It is the ratio of strength of current to the area per unit area. Okay, strength of current per unit area. And this direction is also current density direction. J bar is along the direction of current. Because vector కాబట్టి it is a scalar, of course. Along the direction of current. Current ఏ direction ఉంటుందో J direction కూడా అటువైపు ఉంటుంది. Okay. So many terms we are learning in this current electricity. You have to make a note. These are very, 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 very important regarding examination point of view, please. Now we are coming into the actual point, that is electrical resistance. Electrical resistance, please. Electrical resistance R. Now what is this electrical resistance? You have to understand now. See, in general, electrical resistance is given by V by I is equal to R. That means ratio of potential difference to that of current. Okay. Here we have two graphs for this one. Please make a note. Suppose V potential, if we take on y-axis, current on y-axis, the slope is a straight line, please. So if you observe tan theta here, this is dV and this is di, లేదా delta V by delta A. So here what is tan theta slope? M delta V by delta I. So slope epudu kuda later on we'll begin dealing with Ohm's law, then also I'll explain again. First of all, let us see what is electrical resistance. It is the ratio of potential difference to that of current. Don't take I here because it becomes reverse again slope. I on y axis, V on x axis తీసుకుంటే slope reverse అయిపోతుంది, అంటే 1 by tan theta అయిపోతుంది. ఓకేనా? So slope is given by delta V by delta I. This is nothing but tan theta. And in this case, R is constant, please. Here R is constant. That is why the graph is y is equal to mx passing to the origin. Sometimes R may be variable. Okay? Sometimes R may be variable. And that graph will be like this. You can see here. Here R is variable. That's the point. So what is tan theta here again? It is not constant. Here tan theta is again delta V by delta V only. Okay, here slope. But you can see here R is not constant. Variable. So here this graph is indicating R is constant, and here from this graph R is variable. You can see the graph V versus I. V versus I. Okay? And please, if you take, in sometimes exam they are also giving reverse also. Suppose if you take I here and V here. Okay? Suppose you are getting the graph in this fashion. Okay? ఇప్పుడు ఏమవుతుంది ఇక్కడ చూడండి స్లోపు. ఇఫ్ యూ టేక్ స్లోప్ హియర్ tan theta అప్పుడు ఎంత అవుతుంది? డెల్టా ఐ బై డెల్టా వి tan theta అయినప్పుడు మనకు ఓమ్స్లో ఏం చెప్తున్నారు? డెల్టా వి బై డెల్టా ఐ ఈజ్ ఈక్వల్ టు ఆర్ కదా. కానీ ఇది రివర్స్ అయింది, అంటే ఏంటి? 1 by, అంటే ఇది స్లోప్, వాట్ ఎవర్ స్లోప్ m ఈజ్ ఈక్వల్ టు 1 by tan theta ఇక్కడ. You can see slope is reverse 1 by tan theta, 1 by. ఎందుకంటే tan theta అంటే ఏంటి? డెల్టా V by డెల్టా I. So here slope is becoming reverse, reciprocal 1 by tan theta, please. Clear? So here R, whatever slope, whatever you are saying as R, here it is nothing but 1 by tan theta. Clear? అర్థమవుతుంది ఇక్కడ? ఇక్కడ స్లోప్ ఏమైంది? DI by DR. చూడండి, డెల్టా ఐ బై డెల్టా వి, ఇది tan theta m స్లోప్. అంటే ఇదేంటిది? 1 by r కి సమానం కదా. అండ్ దిస్ ఈస్ tan theta. సో tan theta ఈజ్ ఈక్వల్ టు వాట్ హియర్? 1 by r. tan theta ఈజ్ ఈక్వల్ టు 1 by r. r ఈజ్ ఈక్వల్ టు 1 by tan theta. ఓకేనా? ఇది tan theta కదా. tan theta ఈజ్ ఈక్వల్ టు 1 by r. r ఈజ్ ఈక్వల్ టు 1 by tan theta. Okay? So if you take I on y-axis, V on x-axis, slope will be reversed, di by dv. di by dv ఎంత అవుతుంది? 1 by r కదా. 1 by r. 1 by r అంటే ఎంత? tan theta. Tan theta is equal to 1 by r. So here the slope is 1 by tan theta. Okay? Please observe carefully. These type of questions are asking nowadays in the examination. Okay? Now let us go to the next one. That is specific resistance, please. Clear all of you? After learning about electrical resistance, let us go to the next one. Okay? And please make a note, I already told before, resistance is not depending upon V and I, please. Okay? Resistance does not depend on that one, please. Okay? తర్వాత మీకు మరొక ఫార్ములా కూడా ఇస్తాను చూడండి. రెసిస్టెన్స్ ఈజ్ ఈక్వల్ టు రో ఎల్ బై ఏ, డిపెండ్స్ అపాన్ లెంత్, ఏరియా ఆఫ్ క్రాస్ సెక్షన్. ఇందాక మీకు ఓమ్స్లో ఎలాగా మీకు తర్వాత చెప్తాను. ఒక ఫార్ములా ఉంది ఇందాక మీకు డిఐ బై డివి, డివి బై డి అని ఇచ్చాను అక్కడ. సో రెసిస్టెన్స్ దేని మీద డిపెండ్ ఉంటుంది? డిపెండ్స్ అపాన్ లెంత్ ఆఫ్ ద మెటీరియల్, ఏరియా. And rho is the specific resistance or resistivity of the material. Okay? So it depends upon length. Length మారితే resistance మారుతుంది, area మారితే resistance కూడా మారిపోతుంది, please. Clear? Right. Now let us go to the next one. Very, very important. that is effect of temperature on the resistance. Effect of temperature. Effect of temperature. Okay. So generally if you take the resistance R final is equal to R initial into 1 plus alpha into temperature final minus temperature initial, or R final is equal to R0 initial plus 1 alpha delta T. Here TF and TI are called as final temperature, initial temperature. Final and initial. So this is the formula when the temperature is affected. So resistance final is equal to resistance initial plus 1 plus alpha T. Here alpha is called as coefficient of temperature. Whether temperature coefficient of resistance or resistivity. Temperature coefficient of resistance. You can try it better like that. Okay. Temperature coefficient of resistance or resistivity. Okay. Temperature coefficient of resistance. Temperature coefficient of resistance or resistivity. Okay. So alpha is nothing but temperature coefficient of resistance or resistivity, please. So sometimes we have to use this formula also as a numericals in the examination. Here R0 is initial resistance, for example at 0 degree centigrade or 10 degree centigrade. R final 80 degree centigrade or 100 degree centigrade. Alpha will be given. Sometimes it may be not given. Temperatures are given, T1 and T2. So this is the effect of temperature. Okay. Sometimes in the examination they may be asking some questions also regarding temperature effect. Okay. Regarding the temperature effect. So for that also you have to write down here. You can observe in conductors when you raise the temperature. Okay. When you raise the temperature, what happens? You can see the specific resistance value. Okay. ఇక్కడ దీని మీద క్వశ్చన్స్ కొన్ని అడుగుతారండి మధ్యకాలంలో టెంపరేచర్ పెరిగితే ఏమవుతుందండి ఇది. సో ఆల్రెడీ ఐ గివెన్ ద ఫార్ములా RF, R final is equal to R0 into 1 plus alpha delta T. So alpha is temperature coefficient of the temperature coefficient resistance. ఏదైనా అనొచ్చండి, కన్ఫ్యూజ్ అవ్వసం లేదు. టెంపరేచర్ కోఎఫిషియంట్ రెసిస్టెన్స్ ఆర్ రెసిస్టివిటీ ఆల్ఫా. సో దాని మీద న్యూమరికల్స్ మీకు వస్తున్నాయి. తర్వాత వన్ మోర్ థింగ్ ఐ హ్యావ్ టు టెల్ యూ. See here. So here one more point is ఏంటంటే we'll be doing one thing, the next one. The most important thing they are asking next one in this current density is color coding. ఇది చాలా ఇంపార్టెంట్ అండి. కలర్ కోడింగ్ మీద ప్రాబ్లం వస్తుంది. కలర్ కోడింగ్. సో ఫస్ట్ ఆఫ్ ఆల్ యూ హావ్ టు నో వాట్ ఈస్ దిస్ కలర్ కోడింగ్ అండి. చూడండి, కలర్ కోడింగ్ అంటే ఏమి లేదు, మనకి బజార్లోకి వెళ్ళిన తర్వాత చిన్న రెసిస్టర్స్ ఉంటాయి. వెన్ యూ గో టు మార్కెట్, వెరీ స్మాల్ మైన్యూట్ అనమాట. ఆ రెసిస్టర్స్ మీద కొన్ని బ్యాండ్స్ ఉంటాయి మనకి ఇలా. And these are some colors A, B, C, D. Some colors will be there on this resistor. Okay? ఇవి ఎంత చిన్నవంటే చాలా మైన్యూట్. సో ఆన్ దట్ ఇట్ ఈస్ హైలీ ఇంపాసిబుల్ టు రైట్ ద ఓమ్స్ వాల్యూ. 2 kilo ohms, 3 kilo రాయడం చాలా కష్టం. సో అందువల్ల సైంటిస్టులు ఏం చేశారంటే, సైంటిస్ట్ హ్యావ్ డిసైడెడ్ టు గివ్ సమ్ కలర్ కోడింగ్ ఫర్ దట్ వన్. సో దేర్ బై యూ కెన్ డిటెక్ట్ అండ్ ఫైండ్ అవుట్ ద రిక్వైర్డ్ వాల్యూ. వాట్ ఎవర్ వాల్యూ ఇఫ్ యూ వాంట్ ద రెసిస్టర్, that carbon resistor or whatever thing, you can easily find out అనమాట. అది ఎలా చేస్తారంటే మనందరికీ తెలుసు మనకి ది స్టోరీ, దట్ ఈస్ బీబీ రాయ్ ఫ్రమ్ గ్రేట్ బ్రిటన్. బీబీ రాయ్ ఫ్రమ్ గ్రేట్ బ్రిటన్ హ్యాస్ ఏ వెరీ గుడ్ వైఫ్. సో ఇది ఒకటి ఇవ్వడం జరిగిందండి టు రిమెంబర్ ఈజీలీ ద కలర్ కోడింగ్. అదేంటంటే చూడండి, బీబీ రాయ్, బి రాయ్ ROY. ఓకే. గ్రేట్ బ్రిటన్ G హ్యాస్ వెరీ గుడ్ వైఫ్, VG W. You can see all these. How many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. These are 10 colors. To remember the 10 colors, they have created some letter. B.B. Roy from Great Britain has a very good wife. To remember the color coding things. Here, normally, we have 10 colors. So, here, how the colors will be from starting from the upper portion, dark colors to thin colors. Like that, you have to remember. Dark colors and thick colors to thin colors. So, what he has given is, he has made one table here. Okay. He has made one table. Please make a note. These 10 colors. Starting enti dark nunchi light anamata. Dark annitikante enti black. Okay, next brown. Next red, orange, yellow, green. Okay, dark colors to thin colors. Next blue. This is already brown given. Blue. Okay, violet. And next this is nothing but grey color. And lastly white color. So for color coding system to remember better way in the examination is this B.B. Roy story from Great Britain has a very good wife flow. These 10 colors kuda ela unta manadi kuda starting from top thick colors to thin colors. Black, brown, red, orange, yellow, green, blue, violet, grey and white colors. తర్వాత మనం బజార్లోకి వెళ్ళి when you go to the market and buy the resistor, on that it is very small. ఆ bands బట్టి ఇది ఎన్ని కిలో ohms, what is the resistance value, how to find out. So for example, 4 bands లో first band indicates value, second band also value, third band power అంటే multiple factor power, and last band is indicating the tolerance. Last one is tolerance. Error. See, out of 4 color bands, first 2 bands indicate the value. 2, 1, 3, 4, something like that. Third one indicates the power, multiplication factor. Last one is error, tolerance. At the end, I'll tell you now. See, I'm writing the values here. First band, value in Japan. For example, suppose black, red, orange, silver. Like these 4 bands are given. Black band, red band, orange band, silver. Please make a note here. One thing I am writing here. These 3 are tolerance values I am writing here. One is silver, gold, no color. Okay. So tolerance value mana తీసుకుంటే, for example, for silver it is taken as plus minus 10%. Gold plus minus 5% and no color plus minus 20%. Please you have to remember in this fashion. Silver ki plus minus error anta 10% silver. Please make a note. Silver and gold plus minus 5% tolerance, and if it is no color plus minus 20%. Now see how to identify this color coding. చూడండి ఒకసారి. First black అని చెప్పాడు. So black starting values వేద్దాం మనం. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. See the values? Starting from black 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, na? Now see here. First 2 colors ఏం చెప్పాను? Values అన్న. For example, black 0. Second in the red. Red comes to how much value? 2 value. Third one orange. Orange ఎంత ఉంది? 3. So factor అని చెప్పాను. Power అంటే ఏంటి? Into multiplier. 10 to the power of 3. అర్థమవుతుందా? See, first 2 are values. First 2 have to write values. Third one is multiplication factor. అంటే ఉదాహరణకి బ్లాక్ ఉంది కదా, 10 power 0, 10 power 1, 10 power 2, 10 power 3, 10 power 4, 10 power 5, 10 power 6, 10 power 7, 10 power 8, 10 power 9. These are the multiplicative factor అండి, multiplicative factor. అంటే మనకి ఇక్కడ ఏమొచ్చింది, మనం చూడండి ఆరెంజ్ వచ్చింది, యూ గాట్ ఆరెంజ్ హియర్. సో యూ హ్యావ్ టు మల్టిప్లై 10 to the power of 3. ఆరెంజ్ ప్లేస్లో ఎంత ఉంది వాల్యూ 3. If you get green, 10 to the power of 5. And last one is what I told you, tolerance, plus minus. Silver, how much silver? Plus minus 10%. So what is the final value? 0 to and 2 into 10 ki 1000, 2000. So 2000 ki 10% enta చూడండి, 2000 కి 10% ఎంత? 0000. how much? 200. సో దీనికి ఆన్సర్ ఏంటి? ప్లస్ మైనస్ 200. దిస్ ఈజ్ హౌ టు హావ్ టు రైట్ ద కలర్ కోడింగ్ ఫ్యాషన్. అర్థమవుతుంది మీకు? ఇక్కడ ప్లస్ మైనస్ 10% అంటే ఈ వాల్యూకి అనమాట. దిస్ వాల్యూ, వాట్ ఎవర్ వాల్యూ గాట్, 2000. 2000, what is the 10% of 2000? 200. So plus minus, this is the tolerance. This is the tolerance value. See, like this you have to identify the things. Clear? So very easy method, I told you to remember the color coding method, and one problem is guaranteed in the examination. Okay? We will try to do one small numerical from this one, and we will try to identify. Okay na? Shall I rub this one? BB Roy. Okay. Now see here, I am giving a small numerical. How to solve that one, we'll see. I will put this table because this is useful for us in solving problems. Silver plus minus 10%, gold plus minus 5%, no color plus minus 20%, please. For example, in the examination, they are given a carbon resistor. A small numerical, carbon resistor icharu. He has given a question like this, 4.7. Okay, 4.7. 4.7 or 47, I will check it once. Okay, 4.7 or 47 plus minus 47, అది 4.7 కాదు, 47 plus minus 4.7 into 10 cube. కార్బన్ రెసిస్టర్ ఏమి ఇచ్చాడు? 47 plus minus 4.7 10 cube ఇచ్చాడు వాల్యూ. నాట్ లైక్ దట్, వెయిట్, 10 cube ఇవ్వలేదు, ప్లీజ్ వెయిట్. 47 plus minus 4.7 కిలో ఓమ్స్ ఇచ్చాడండి, కిలో ఓమ్స్. సో కార్బన్ రెసిస్టర్ 47 plus minus 4.7 kilo ohm. Now we know what is 1 kilo ohm? 1000 ohms. So put the value here. 47 plus minus 4.7 into 10 cube. Put it inside. 47 cube and then the 1000 plus minus 4.7 into 10 cube. Just చూడండి ఒకసారి how to solve this, I'll tell you. 47,000 plus minus 4.7 3 zeros. And అర్థం ఏంటి? 4700 1 decimal, 4,700. ఒకసారి గమనించండి, this 4,700 is how much percent of this one? How much percentage of 47,000? We'll try 10%. 0, how much? 4,700. That means this 4,700 is nothing but 10% of this value. Therefore, 47,000, okay, plus or minus 10%. ఈ plus or minus 10% అంటే ఏంటి? Come to here, silver. 10% ఏంటి? సిల్వర్. సో దిస్ ఇస్ వాట్ సిల్వర్ అనమాట. అదవుతుంది మీకు. అంతేకాకుండా ఇది ఒకసారి చూడండి, 47 ఇదేమో 3. సో ఐ రైట్ యాజ్ 47 into 10 cube plus minus 10% means what? Silver. So silver. So what is 4 from this one? You can see 4 what? Yellow. 4 means yellow, first color. 7 means what here? Blue. చూసుకోండి ఒకసారి. 7 means what? Blue. Next 10 power 3. 10 power 3 again orange. Okay. And finally 10% means silver. 10%. So this is the color coding value. So in the examination, if they give in such a fashion, you have to solve like this. Yellow, blue, orange, silver. Yellow, blue, orange, silver. Please watch carefully. So check cheskondi. 0, 1, 2, 3, 4, 5. Okay. 6, 7. Oh, 7 వచ్చింది మనకి వాల్యూ ఇది 7 కదా ఒకసారి చూడండి 7 please 4 into 1 2 3 4 4 is yellow and we got 7 ఇక్కడ 7 అంటే ఏంటి వైలెట్ ప్లీజ్ 7 వైలెట్ అండి బ్లూ కాదు జాగ్రత్తగా చూసుకోవాలి బికాస్ కలర్స్ యూ హావ్ టు వాచ్ కేర్ఫుల్లీ 7 47 కదా 4 belongs to what orange 4 belongs ఏంటి చూడండి 4 1 2 3 4 yellow 4 belongs to yellow అండి and 7 belongs to violet. So yellow, violet, orange, silver. Yellow, violet, orange. This is the correct answer. So in the examination you have to remember in your brain that B.B. Roy story and also these 3 tables. Silver, gold and no color. No color means tolerance plus or minus 20%. Okay? Silver plus or minus 10%. Gold plus or minus 5%. So like this you have to solve the numericals. Now let us go to the next topic in this one, that is Ohm's law please. I hope that you understood this color coding. Very easily I told you how to solve the problems please. The only thing is you have to remember that B.B. Roy story and thereby form the table. One problem is guaranteed from this one, color coding. And try to remember the values please. That gold, silver and no color. Okay? Gold is plus minus 5%, no color plus minus 20 and silver is plus minus 10% please. Okay. So those are the values. Silver is plus minus 10, gold plus minus 5, no color plus minus 20%. Now let us go fastly into Ohm's law please. Another important one, Ohm's law. What is Ohm's law? See, we know Ohm, Sir Simon Ohm is a great mathematician and physicist. So what he is given is, for example, there is a conductor like this. PQ is a conductor. Suppose I is the current flowing in this one and V is the potential difference. So what he is saying is, V directly proportional to I, okay, that is potential difference is directly proportional to I, or delta V or V is equal to K into I, or delta V is equal to Ri. This K is constant which is equal to electrical resistance of the conductor. Electrical resistance of the conductor. Therefore, V by I is equal to R. Or delta V badal V could watch V by I is equal to R. So it is the ratio of potential difference applied to that of strength of current. Therefore, SI unit of potential is volt, current is ampere, that is equal to 1 ohm. So ohm symbol also you can write like this, which is also called as omega in mathematics. So SI unit of resistance is ohms. Clear? So according to Ohm's law, this just now I given a graph also for you, VI graph. 2 graphs, one is variable resistance, constant resistance. So in this you have seen the slope also tan theta, R is constant and R is variable 1 by tan theta వచ్చింది అక్కడ. So this is mainly about the Ohm's law, and from this the questions will be like this. What are ohmic conductors and non-ohmic conductors? ఇందులో క్వశ్చన్స్ ఎలా ఉంటాయండి ఎగ్జామినేషన్లో, వాట్ ఆర్ ఓమిక్ అండ్ నాన్ ఓమిక్ కండక్టర్స్. ఓకేనా? సో బిఫోర్ గోయింగ్ టు ఓమిక్ అండ్ నాన్ ఓమిక్, one more examination question. See, this V is equal to IR, Ohm's law, is in scalar form. This formula is a scalar form. Okay? Now suppose in the examination if they ask in vector form of Ohm's law, then in the place of V we will write field, electric field intensity. In the place of I will write current density, J. In the place of R I will write rho, specific resistance, which is constant for a given material. So the same equation, Ohm's law in vector form is E bar is equal to J bar into rho. This is the vector form of Ohm's law. Now we already know what is the reciprocal of specific resistance, resistivity, conductivity. The reciprocal of resistivity or specific resistance is equal to conductivity. 1 by rho is equal to sigma. So in this place I can write like this. E bar by rho is equal to J bar, or this one 1 by rho I can write sigma. That means E bar into sigma is equal to J bar. Okay, because 1 by rho is equal to sigma kada. Reciprocal of specific resistance is resistivity or conductivity is equal to conductivity. So Ohm's law can be also written in this fashion. E bar into sigma, conductivity is equal to J bar, current density. Okay, so these are some examination questions. Please make a note. Very, very important. Right. Now, ఇప్పుడు చెప్పాను కదా ohmic conductors అంటే ఏంటి? Those metals or conductors obeys Ohm's law or ohmic. Those doesn't obey Ohm's law are non-ohmic. అర్థమవుతుందా? సో ఏ మెటల్ అయితే Ohm's law follow అంటే V proportional to I, straight line passing through the horizontal graph, those all are ohmic conductors. Those all are ohmic conductors which obeys Ohm's law. Which obeys Ohm's law. And those which does not obey Ohm's law, those does not obey Ohm's law are called as non-ohmic. Non-ohmic. So Ohm's law, if you observe the graph, is in this fashion, straight line, passing to the origin. So here, delta V by delta I is equal to tan theta is equal to R constant. Okay? Non-ohmic conductors ఏమవుతుంది? Graph will be somewhere like this, not straight line. Graph is not straight like this, or it may be like this, like PN junction diode. This is forward bias condition, reverse bias. ఇది ఎక్కడ? PN junction diode లో. In PN junction diode you can take non-ohmic, or you can also take vacuum tube. Vacuum tube. Okay, and the best example for semiconductors are germanium, silicon. Germanium and silicon. ఇవన్నీ కూడా మనకు non-ohmic conductors గా తీసుకోవచ్చు. Please, these does not obey because you can see the graphs are not straight line passing to the origin. Okay, these are not straight line passing. అదే విధంగా metals at high temperature, please make a note. Metals at high temperature, you can see up to here it is okay. After this you can see curve is forming. So at a high temperature, Ohm's law again, I mean for metals it again fails. Though the graph is not straight line, only at constant temperature. What is Ohm's law definition? At constant temperature. Okay, V proportional to I. So when the temperature is very high, again metals does not obey Ohm's law. You can see small curve is coming. So Ohm's law and enti at constant temperature V proportional to I. Okay, and you can see all the graphs. Those obey Ohm's law are ohmic conductors. Those doesn't obey are non-ohmic. Example: germanium, silicon, vacuum tube, PN junction diode, etc. etc. All these are best example. Okay na? ఇంకా కావాలంటే మరొకటి కూడా తీసుకోవచ్చు. వాటర్ వోల్టామీటర్. Water voltameter, another example. Water voltameter. Okay, all these are non-ohmic materials. Okay, and please make a note. Ohmic conductors are constant. Okay na? Ohmic lo ఎందుకంటే directly proportional కాబట్టి. Constant లేకపోతే non-ohmic అవుతుంది. Clear? So these are some bit questions in the MCET examination and NEET. They are asking graphs also regularly. Those also have to be very thorough regarding graphs. Clear? Right? Clear? Any doubt? So we have differentiated between ohmic and non-ohmic conductors here. Any doubts now? Right. Now we'll enter into the series and parallel connection of resistances. Series and parallel connection of Resistances, very very important one. See, derivations I am not deriving because we are concentrating on M set only. Okay, so please make a note of that one. So this is the resistance. Okay, single box, potential, current, or now resistances are connected in series kada. You can take any number, V plus minus, this is R1, R2, R3. So in series connection, the effective resistance Re is equal to R1 plus R2 plus R3 dot 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 Rn. That means the effective value will be more because I is constant, same I is flowing through all the circuit, and V varies, potential varies please. So here the potential difference will be different, V1, V2, V3. I is constant, potential is equal to V1 plus V2 plus V3. And we know what is V from Ohm's law, I into R. And we know what is V1, you can calculate it, I is constant, I into R1, I into R2, I into R3. If you take away the constant I outside, R is equal to R1 plus R2 plus R3. Like that easily you can derive. So in series connection the effective value is more, the sum of all the resistors. If n resistances are there, R1 plus R2 plus R3 up to n you have to add up. Okay. So this is series connection, please make a note. Now let us go to parallel connection. Parallel connection ఎలా ఉంటుంది చూడండి ఒకసారి. This is the single box. This is the single box. Current, resistance. So parallel connection, if you observe carefully, see here. This is parallel connection of resistors. You can take number of resistors. మీ ఇష్టం ఎన్నైనా తీసుకోవచ్చు. This is P and Q ends, plus minus current. Now if you observe carefully, current is distributed. See here, I1 is coming here, I2 is coming here, and I3. Again all together gives rise to again I. So in parallel ఏమైంది ఇక్కడ, I is distributing as I1 plus I2 plus I3. And which is constant? Potential is constant. Potential difference is constant. I is varying. And we know what is from Ohm's law, V is equal to IR, or V by I is equal to R, or V by R is equal to I. So here we put V by R, I, as I said, V is constant. V by R1 plus V by R2 plus V by R3. If you take common, then V gets cancelled. So what is the effective resistance? 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3 dot 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 n cells. So n resistors. So like this you can find out the value also please. Okay. So ikkada the effective value decreases in parallel connection. If you want less value, go for parallel. If you want for more value, go for series connection please. Clear? Right. And please make a note, in parallel current is distributed, varied, potential is constant, and in series connection please, okay, in series current is constant and V is varying. These things you have to put in your mind, very very important. Okay. Now let us define what is terminal voltage, EMF, etc. We'll see what is meant by terminal voltage. What is terminal voltage please? Okay. For example, see this circuit here. For example, a small circuit I am drawing. Some battery. Okay. And for example, is having some internal resistance. Okay. Right. Now here, plus minus, current is flowing. Take some value for this one. Some 4 ohms. Like internal resistance, take some value 1 ohm. Like a battery also you can take some volts, EMF, 10 volts. Now what is terminal voltage? The voltage between the two terminals of the battery is called as terminal voltage. The voltage between the two terminals is called as terminal voltage or potential difference. Terminal voltage or potential difference. The voltage across the terminals of the battery, plus and minus, that is called as terminal. It is also called as potential difference. And we have an equation also, E by external load resistance R plus small r is equal to I, which is equal to V by R. Now here you have to make a note, when E is equal to V, okay, and when E is greater than V. Okay, so what happens is, for example, we have a relation here, you can observe carefully. See this one, E by big R plus small r is equal to V by R. Okay, లేదా E by V is equal to big R plus small r plus capital R. That is, E by V is equal to 1 plus R by R. Or E by V minus 1 is equal to R by R. Very, very important relation this one. Regarding internal resistance, external load resistance, potential difference or terminal voltage and EMF. And EMF already you know it is also work done by moving the unit positive charge entirely throughout the circuit. That is called EMF, electromotive force. Okay. So this relation you will be using in numericals, please. That is, E by capital R plus small r is equal to small I, is equal to V by R. This is terminal voltage or potential difference, and this is EMF. Sometimes E is equal to V in open circuits. In open, that means it's a closed circuit, open circuit. Okay, E is equal to V, and in sometimes E is greater than V. E is greater than V, please. So this point is very, very important. You can observe here the equation చూడండి ఒకసారి ఇది. ఇక్కడ అబ్జర్వ్ చేయండి. E by V minus 1 is equal to R by capital R, or E by V minus 1 into capital R, small r. So by using this formula you can calculate the internal resistance of the battery or the cell. Okay. So open circuit లో ఏమవుతుందంటే E is equal to EMF is equal to the terminal voltage or potential difference. And sometimes in closed circuit EMF is greater than the V, terminal voltage E. E is greater than V, please. Okay, and we have formula also, that one I will give you later on while doing numericals. While doing numerical problems I will tell you that formula. Okay. So here we are having one formula, see, observe carefully. V is equal to E minus R. V is equal to E minus R, or V plus IR is equal to E. What is this equation? What does this equation tells? V, potential difference or terminal voltage is equal to E minus IR. Or take to this side, E, V plus IR is equal to E. What does this mean? So E is equal to V plus something. That means E is always greater than V. EMF is always greater than V. Only in some open circuit cases E is equal to V. Okay, when current is not flowing, of course, in some cases. Okay, otherwise V is equal to E minus IR or V plus IR is equal to E. So from this equation it is very clear, EMF is greater than potential difference. Okay, so V plus IR, V plus is equal to this thing. V is equal to E minus this thing. So it is less. Okay, E is greater, V is less than E. అదవుతుందా? ఈ పాయింట్ మాత్రం గుర్తుపెట్టారు, ఎగ్జామినేషన్లో అడుగుతున్నాడు. సో దిస్ ఫార్ములా ఇస్ వెరీ వెరీ ఇంపార్టెంట్ ప్లీజ్, రిగార్డింగ్ ఈఎంఎఫ్, టెర్మినల్ వోల్టేజ్ అండ్ ద రిలేషన్ బిట్వీన్ ఇంటర్నల్ రెసిస్టెన్స్ అండ్ అదర్ థింగ్స్. ఓకే, so have you understood the point here? Here the main formula V is equal to potential difference is equal to E minus IR when current is flowing, or V plus IR is equal to E. That means E is greater than V. Okay. Now let us go to the next thing. Cells in series, parallel. Very very important things. Cells in series and parallel. See, in the examination they are asking cells in series or batteries in series. See, cells in series you can go as usual like this. You can go for n cells. So if you observe pattern here, this is minus, plus, minus, plus, minus, plus, minus, plus, minus, plus, so on and so forth. So what is happening? One plus, another minus. Again plus, minus. So this is normal way. Normal way. In some cases you can see here, minus, plus, minus, plus. Now see what happened. So here plus again came, minus. Chudandi okasari case. You observe this case. You observe this case. Here plus minus. Here plus is coming again. Again you can change it. Minus, plus. So if you observe carefully, these are in normal order. Minus, plus, minus, plus, minus, plus. But here minus, plus, minus, plus. Here plus is coming. So polarity is changed here. Polarity is changed. In such cases, the formula varies. Series connection low, effective EMF is given by E1 plus E2 plus E3 plus dot 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 En. Okay? E1 plus sum of all the values. Okay? If n values are there, E1 plus E2. If all the values are equal, Ne. E net is equal to. If E1 is equal to E2 is equal to E. N are there. Ne. Series flow. Suppose polarity is changed. In this case, effective EMF is equal to E1 plus, this is E1 anukondi. Idi E2 anukondi. Idi E3. So E1 plus E2 minus E3 you have to put. Because polarity changed. When the polarity changed, then what happens? Normal method only, E1 plus E2 plus E3. Whichever is polarity change, subtract that one. This is how you have to find the effective value. Okay? And for internal resistance, it won't change. Re is equal to R1 plus R2 plus R3 plus dot 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 Rn. Okay? Even the polarity change, internal resistance value here mardu. Sum of all the resistance because it's series connection. Now let us go to parallel. Let us go to parallel connection. Parallel connection ఏమవుతుందో చూద్దాం. See, in parallel connection, slightly different. Cells in parallel. Cells in parallel. See here. This is one cell. This is another cell. This is another cell. Okay. Like that you can take n cells if you are interested. Okay. P and Q. So minus, plus, minus, plus, minus, plus like that. So this is one pattern. So in this case, if you get effective EMF, then E1 by R1 plus E2 by R2 plus E3 by R3 plus dot 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 En by Rn by resistances 1 by R1 plus 1 by R2 plus 1 by R3 plus dot 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 1 by Rn. So this is the formula for effective EMF in parallel connection. E net is equal to E1 by R1 plus E2 by R2 plus E3 by dot dot En by Rn 1 by R1 plus 1 by R2 plus 1 by R3 so on and so forth. Suppose ikkada polarity change anukundam. Ela ante chudandi. Normal case kaakunda suppose minus plus one has come like this. See PQ here plus minus and remaining mana mamule minus plus. Now you can see this one polarity is changed E2. E1 and E3 are normal way. So in that case what happens? E net when polarity is changed. When polarity changed, then what happens? Same E1 by R1. This one polarity changed minus idi. Ante ee rendu okate E1 by R1 minus E2 by R2 plus E3 by R3 whole by 1 by R1 plus 1 by R2 plus 1 by R3 so on and so forth. Remaining all same. Internal resistance there is no change here. Only thing wherever the polarity change that you put minus. E1 by R1 this polarity change. Therefore, minus E2 by R2 remaining E3 by R3, please. So this is how we have to calculate for the cells in series and parallel, please. Okay, any doubts? Right. Now let us go to the next interesting topic, very, very important. Okay, those are nothing but Kirchhoff's laws. Very, very important, Kirchhoff's laws. Okay, we are entered into the next interesting topic, that is Kirchhoff's laws in electricity, please. Okay, na? Kirchhoff's laws. Kirchhoff's laws in electricity. Very, very important. See, a scientist named Kirchhoff has given two laws. He is given two laws. One is law of charges, and next one is law of voltage. Kirchhoff scientist has given two famous laws, law of charges and law of voltage. So first one, what is law of charges? See, for example, this is a junction, namely O, and at this junction, say some currents I1, I2, I3 are coming, I4, I5 are going away. Now, according to Kirchhoff's first law, it is also called as junction theorem. It is also called as junction theorem. So, he has given two statements. What is the algebraic sum of the currents? What is meant by algebraic sum? Algebra and artham plus minus, conventional sign. The sign convention what you have taken. Suppose if I take towards the junction as positive, going away I will take negative. Or if you take towards negative, going away I will take positive. Any sign convention you can take. So, according to him, the first one is the algebraic sum of the currents meeting at any junction in a circuit is equal to 0. This is also called as law of conservation of charges. This is also అందుకే law of charges and law of conservation of charges. ఎంత కరెంట్ అయితే జంక్షన్ కి వచ్చిందో అంత కరెంట్ మళ్ళీ వెళ్ళిపోవాలి. So, okay, algebraic sum of the currents meeting at any junction is equal to 0, or total sum of incoming currents is equal to total sum of outgoing currents. Junction వైపు ఏవి వస్తున్నాయి చూడండి కరెంట్స్, I1, I2, I3. So these are coming, and this should be equal to what? Outgoing, I4 plus I5. So here you can see total sum of incoming currents is equal to total sum of outgoing. Or you can apply algebraic sum of the currents meeting at any junction in a circuit is equal to 0. Algebraic sum and coming positive. So I1 plus I2 plus I3 coming. Going away negative. So minus I4 minus I5 is equal to 0. This is another way of representing the Kirchhoff's first law. Clear? So this is also called a junction theorem. It is also equal to law of conservation of charges. Total incoming currents is equal to outgoing currents. Now let us go to the most important one, second one. See, many people, the second one they'll mug up and go to the examination. Okay? Because they feel second one is very tough. But if you understand better way, second one is the very easiest one, second law. I'll try to tell in easy method. Second law. Second law of Kirchhoff. Second law of Kirchhoff's. See, second law of Kirchhoff, you can say in two methods again. Sigma V is equal to 0. What is sigma V here? That means the algebraic sum of the PDs, potential difference, in a closed circuit, or closed loop is equal to 0. That's the point. The algebraic sum, I'll explain with a figure. I'll give you a small figure here. For example, see here, I am giving with some values, it is better. 1 ohm, one battery is here. Okay, resistance is given here. Take some value, this is also 1 ohm. Okay, and here also some resistance. One more battery. That also I am giving value as 9 ohm, 9 volts, and this is 3 volts. plus minus. Resistance value also given here, 2 ohms, 1 ohm, and here also some 2 ohms. Let us take some example. Okay, now we can observe A, B, C, D. It's a closed loop. So what he's saying is sigma V is equal to, that means algebraic sum. You can also take like this. The algebraic sum of the potential differences in a closed loop or closed circuit is equal to 0. Algebra means conventional sign. In what way you are going, in which path you are going, along the direction of current or opposite to the current. So this is the main statement given by Kirchhoff. Sigma V is equal to 0 means the algebraic sum of the potential differences, that means product of current and resistances in a closed loop or closed mesh or closed circuit is equal to 0. We'll try to explain this one. For example, see this figure. So what I'll do, see, before going to this one point I want to tell regarding resistance and regarding cell. See, regarding resistance, if you observe carefully, see, for example, this is the path I am taking. Okay? And the path you can take along the direction of current, or you can take against, like this, anti-clockwise. You can take clockwise or you can take anti-clockwise. Please make a note, for resistance it is different and for cell it is different. Okay? Resistance cannot be scored. For example, you are going along the direction of current. If you are going along the direction of current, you can take, there will be a potential drop, negative. And for cell, what happens? There is no effect of current direction. If you are going from positive to negative, take negative value. If you are going from negative to positive, take positive value. This is the difference between cell and resistance. Resistance ki, when you are going along the direction of current, potential drop, negative value, negative potential. When you are going against the current direction, take plus value. Current direction lo veltunnappudu potential drop avutundi. Current ki opposite lo veltunnappudu potential gain avutundi. Ekkada resistance lo. Cell lo effect undadu. In case of cell, plus to minus, take minus value, minus to plus, take plus value. For example, we will put here. Deentlo pedadam. A, B, C, D, A. Closed loop. So I am following this function like this, clockwise. Okay? That means along the direction of current. So for cell, what happens? Plus to minus to plus. Plus. Just now I told you, minus to plus. Plus. Now I am going along the direction of current. So what happens? There will be droppage of current, voltage. So minus, what is the current here? I into resistance and the 2 ohms. Current value ichara? Evaledu. So I into R. Same. Along the direction of current again, potential drop. Minus, same current will be there here also. Same current. So minus I into 1. Again same direction of current. Droppage. Minus I into 2. Now see, I came to the cell now. Now plus to minus. So droppage. Minus 9 volts. Plus to minus. Now again coming to here. So what? Direction of current again. Minus 1 into I. And finally you can see here. Again you are coming here. So loop is closed. So this is how you have to apply the formula. And what? This is a closed loop equal to 0. Open aithe equal to 0. It is a closed loop kabatti. This is how you have to apply. Okay? So in which direction you are going? Clockwise or anti-clockwise? Current direction lo veltunnappudu potential drop resistance ki, and cell there is no effect for the cell. Cell value minus to plus అయినప్పుడు plus value, plus to minus అయినప్పుడు minus value తీసుకోవాలి cell లో. But whereas in resistance, along the direction of the current if you are going path, there is potential drop, and opposite if you go, there will be potential gain. You can try in the next direction. So like this you have to take, and finally you have to put 0 because the statement sigma V, the algebraic sum of the PDs in a closed circuit is equal to 0. What is PD is there? Product of current and resistances in a closed loop. Okay? Please note down. And what I will do is, we have some numericals also for this one regarding Kirchhoff's laws. Those numericals and remaining part, whatever left over, I will try to complete in the next part of current electricity. This one you can take it as part 1 of current electricity. In part 2, I will make you to do some numerical problems. Okay? Right.